I bet a lot of us don't know which way we are heading. On land, a general direction is okay, but if you are at sea, you need to be very precise. Luckily for us, we have GPS and Gyrocompass to show us where to go. Hello guys, welcome back to my channel, and today we will discuss what is heading and how you can find out your exact heading. So what is heading? Say you have a vessel here and you point your vessel's head and draw a straight line. Then from your position you draw a line to the north. We'll discuss about the north later on, and the angle it creates from the north to the vessel's current direction. This angle is your present heading. Are we clear? Now you might say that I have drawn this north line in a curvature, and that's correct because we are on a globe and our lines are not straight. But thanks to our marketer projection, in our maps all our norths are pointing straight up. So we first have to know what is north and how we can find our angle of the vessel's heading. So shall we? So where is north? Well, in earlier times people used to say when the sun rises, you face towards the sun and your left hand side will be the north. But yeah, that's not good for our everyday marine operations. So there are few different norths, and if you want to know more about north, I made a video a few days back and you can look it right here, and I will put the link in the description below also. Now there are few norths that we need to be concerned about. In our normal heading with the gyrocompass, we are mainly concerned about the true north, which is the north rotational axis of the earth, is this one. And in all marketer projections, the point straight up, a straight line showing you the grid north, and this is all the grid north. And there is also a magnetic north, but there is a lot of problem with the magnetic north, as the magnetic pole is not at one single place. It is roaming around at a breakneck speed, almost 60 to 65 km in a single year. But here for this video we are mainly concerned about the true north and the grid north. So the question is how we can define what is our heading. How do we measure the angle with reference to the true north? So let me show you here. Suppose this is the true north and this is your vessel's heading, but you don't know which way the heading is. Your gyrocompass may be showing you a direction, but you don't know whether the direction is correct or not. So how do you measure this angle? Well, for that you need to have a reference azimuth or a reference angle to a position or a point either on earth or beyond, and whose angle, whose azimuth with reference to true north you already know. And we will come back to that a little later. But before we come back to that, we must know what are the main factors that can cause our heading to go bad. Okay, to find our exact heading, the very first thing we need to take care about is the alignment error. The alignment error is the error between the angle of your vessel's fore and aft line and your gyro's fore and aft line. Suppose in a vessel, if this is vessel's fore and aft line and you put your gyro not exactly aligned with the vessel's fore and aft line, and this is your gyro, the way the gyro is heading, so this angle becomes your alignment error. So this is the very first thing that you need to take care of, is the alignment error. The main thing that you need to take care about, that you have to determine the vessel's fore and aft line and then try your best to put your gyrocompass as close to this line as possible. Okay. Okay, the point number 2 is we need to align our vessel's gyro exactly with a reference azimuth, because the azimuth is the angle from the true north. So we need to know where is the reference azimuth, and we need to measure the angle from that reference azimuth to know if there is any azimuth error into our gyrocompass or not. So how do we do it? And today in this video we will be discussing more about how we can easily find the azimuth angle from a reference azimuth, and we can correct our gyro. The most common way we surveyors do in the marine is to take a sun azimuth or the sun angle. So how does that work out? Let's say early in the morning the sun is somewhere here near the horizon, and this is your vessels, and this is your vessel's fore and aft line. You determine your position on the vessel first, and then you measure the angle to the sun. You measure this angle. Let's say this angle is A. With the help of a sextant you can easily measure this angle, and you know your position. So you have two kinds of data. One is a position and one is an angle, but you need another data that is called time. So at exactly what time, at exactly what position you have measured this angle, that is very important. Time is very important. Okay. Now there are some websites which I will show you later, and I will also put the link below, where you can go and find the sun's azimuth, the exact azimuth of the sun with reference to the true north. Okay. Suppose this is the true north, and you have found the angle of the sun's azimuth to be angle B. So at an exact time of your observation, you find out the angle of the sun's azimuth at exactly in your position. Okay. The sun's azimuth will vary depending on the time and the position. So you have to find out the sun's azimuth exactly, and you have measured the angle from the vessel's bow to the sun. So now I have the full data to find out what is my heading to be exact. So what you do actually, when you are taking this observation, you have to synchronize your clock, you have to start logging your heading, and then you have to go and measure the angle to the sun. So with this data, suppose the sun's azimuth that we have found is to be 89 degree. Okay, and the angle that you have measured, this angle A, is found to be 45 degree. Okay, you have to measure the angle as precisely as you can. So what will be the heading? That will be B angle minus A angle. So that is 89 degree minus 45 degree is equal to 44 degree. So your heading, your azimuth of your vessel's fore and aft line should be 44 degree. But you are logging your gyrocompass, right? If you are logging your gyrocompass, you found that your gyrocompass is showing 46 degree. That means your gyrocompass is showing 2 degrees high. So you apply that correction minus 2 degree. You apply that correction to your gyrocompass, and that's how you can find your exact heading.